How's it going, everybody? In this video, we're going to start diving into the dynamic routing portion of our series. Now, there's a lot to cover, and we're going to go through this pretty systematically. We're going to start off with RIP. You can say what you like about RIP. At the end of the day, it's a routing protocol, right? And the main driver that I have for talking about RIP is you never know whether you're going to be working on a customer's network that is all Cisco gear and top of the line stuff and a multi-million-dollar deployment, or if you're going to be working with a customer that has a budget that is the limit of their credit card, which might only be a few $100s, and buys all really cheap gear, and the only routing protocol that might be supported is RIP. So regardless of the situation, I want you guys to be familiar with different scenarios and stuff like that. So we will be deploying RIP here in AS200 with RIP, or specifically RIP version 2, and things like that. We're going to dive into the details of how RIP works at a high level. We're going to see, what makes RIP tick, why RIP was developed, some basic stuff like that. Kind of just a little bit of a history lesson behind it, and then we're going to look at getting it up and running and how it all works and stuff like that. So that's basically what this RIP section is going to be all about. So you can rip on RIP, pun intended, if you want to, but if you're like me and you take everything quite seriously about what we do for a living, I definitely think it's a good idea for you guys to take it for what it is and not what it isn't. So with that being said, I'm going to go ahead and bring this down here so we have a little bit of whiteboard space. The very first thing we need to dive into is understanding the concept of distance vector. So because RIP in its basic setup is a distance vector routing protocol. So RIP stands for the Routing Information Protocol. RIP. Now, it's been around for a really, really long time. It started out with V1 or version 1, and then it was upgraded to version 2, which added more things like classless routing and things like that. So for those of you that are not familiar with class-full routing, I'll cover that real briefly. Class-full routing, and I'm not going to go into a ton of detail on it, but class-full routing basically routed based off of the major network. So in other words, your 10/8, your 172.16/12, and your 192.168/16. These are considered major network numbers. If you have that route in the routing table and you can forward towards it, you would. Classless routing takes the concept of 10/8 and allows you to advertise both the prefix 10.1.1.0 and add a subnet mask of /24 and still forward it, because even though this is considered to be a class A range, a /8, the subnet that you're being advertised might be a /24. So because of the fact that you're using classless interdomain routing, or CIDR, in order to make it unique out of that 10/8 is the reason why classless routing is so popular. Now, when we talk about RIP and its basic setup, we are talking about RIP version 2 specifically, which enables classless routing, which means you are going to carry, you're going to be advertised and propagated a subnet mask. Because if you look at class-full routing, there is no subnet mask. You just get a prefix. You don't get an actual mask. So you get a subnet mask. Was added to classless routing, and you're good to go there. Now, basically the idea here is if you have a match and you can forward it, you're going to go do that, which is also referred to as the longest match routing, right? You have longest match routing. If you don't have a longest match, which this would be considered to be a longest match, if you don't have a longest match, you're going to be routing based off a default route. Hence the word default. If you don't have a more specific route, you're going to go down this in the order of propagation, or I should say recursion. Number 1, then number 2. If you don't have a default route, you drop the packet. If you have a default route, you forward the packet. If the longest match is found, you forward the packet. If you 3, no default, you drop the packet. Basically, that's what it comes into play. RIP brings into play the concept of a distance vector routing protocol. Distance means how far, so metric, and vector means which way. So distance vector, which way. So outgoing interface. Outgoing interface. Okay. Now with that being said, the way that RIP does this is based off of a value of metric wise of 1 through 16, but this one right here, 16, is inaccessible. Inaccessible, if I could write. So because it's inaccessible, that's as far as you can go. Now this means 1 through 15 are your valid ranges. What does this actually mean? This means that you can have a maximum width. So going this direction, width of the network is 15 hops, right? Or a minimum would be 1 hop. So anything in between there would be acceptable to you. You have 5 and you've got 10. If you hit 15 hops, that means you've reached the end of the network. So in other words, your RIP network can't be very big, can't be very wide. Now, that can be looked at from a north-south perspective, so routing from the endpoint to the default gateway. If the default gateway and the edge of the network to get you off the RIP environment, or the edge of the RIP environment, and where the start of the RIP environment is 15 or more hops away, or I should say 16 or more, you're not going to be able to reach it. RIP's going to go, well, I don't know how to reach that, man. So in this case here, 1 through 15, those are valid metric capabilities, and that's where you need to understand how RIP comes into play. Now, the way that RIP is going to determine this is based off the hop count. So when we talk about hop count, what does that mean? 1, 2, 3, 4, 5. So if this is the source or the start of wherever you're trying to go, this would be 1 hop, this would be 2 hop, this would be 3 hop, this would be 4 hops. Okay, so if I have a LAN segment sitting here behind this router and a LAN segment sitting behind this router, that LAN segment on the remote end, the destination in this case here, this right here is 4 hops away. Now it doesn't matter what the link speed is between the routers. RIP does not care. RIP doesn't care if it's a 100 megabit interface or 200 gigabits. It doesn't care. Because you could have a scenario where you have multiple links between these guys, a link here, a link here, a link here, and a link here. And let's say the top one is 100 megabits across the board. And this is 1 gig across the board, right? It looks like it's 16, but it's 1 gig. Regardless of what's going to end up happening, RIP will see 2 different paths to that destination. One out the top link here, go in this direction, and then 1 link out this one. Because RIP has no way of differentiating between link speeds. It's not OSPF, it's not EIGRP. It doesn't have the ability, or ISIs for that matter, with a different metric value. Those protocols have the ability of differentiating link speed where RIP does not. It's going to look at source to destination. I only know what I know, which is 4 hops away. I've got 2 different ways to get there. Will the router start to load balance? To a certain extent, yes. But it's not really a load balance, it's a load share. So you can obviously send 10 times the traffic over a gigabit interface that you can 100 megabit, because it's 10 times faster. So for every 1 packet you send, or for every 1 flow, you're going to send 10 packets out the gigabit interface and then maybe 1 out the 100 meg, because that might be the load distribution that the forwarding engine figures out. But that's a whole nother topic in and of itself. Now, when we talk about those details, that's really where the capability comes into play. Now, let's talk about how RIP detects loops and how it prevents loops, because that's really, really important. The first thing that we have to understand is RIP uses a concept known as split horizon, or with poison reverse. So split horizon means that you never advertise a route out the interface it was learned in on. In other words, if I have a router here and a router here, then I have a LAN segment here and I'll have a LAN segment here. I can take LAN segment 1 and LAN segment 2, I can propagate them this way, and then this route's going to get propagated this direction, this route's going to get propagated this direction. So you'll see 2 and you'll see 1, they'll be able to reach each other, right? This will work all day long, because if this is gig 1 and this is gig 2, then you'll be squared away, because the route updates are coming in 2 separate interfaces. But it's different when you have, say for example, a tunnel, where you've got this guy right here and you've got a couple of spokes hanging off here. Maybe you've got an internet cloud sitting here and you're running DMVPN over the top. We will be talking about this later on in DMVPN, where you've got tunnel 1 here, you've got tunnel 1 here, and you've got tunnel 1 here, right? Well, if I'm learning a link here and a link here, I got 1 and 2 down here, I'm going to be learning both 1 and 2 on tunnel 1, which means that what will end up happening is any traffic that's learned in from spoke 1 about LAN segment 1 at spoke 1 will be learned by the hub. However, it will not be sent back out towards the spoke at branch 2 or spoke 2 for it to learn about that. The way that you can affect that is to disable split horizon, but that can bring into other problems. We'll talk about that more in detail when we get into scenarios like that. Now, poison reverse is a advertisement of a route out the interface it was learned on, but with a metric of unreachable. In other words, 16, because it's not a viable route. You're basically saying, you can't use this route. So again, because 16 is inaccessible means that the route is now dead. And a lot of times what will end up happening is that'll happen when a link goes down, maybe a router reboots or something happens in the network. RIP will detect that and send an update outbound with poison reverse saying, okay, you know what? This destination is no longer available. This prefix has gone down. And then that will get propagated to the rest of the network, and then the routing table will go, oh, okay, no harm, no fail. I'm going to go ahead and remove it from my routing table because it's no longer reachable. And then when it comes back online, RIP will go ahead and propagate the information. That's basically how that comes into play. Now, that's some of the high-level operations to how RIP actually does its job. So let's talk about some of the details regarding how RIP figures out who he's connected to and how routes are propagated and things like that. So by default, RIP has an administrative distance or believability of 120 on the Cisco routers that we're going to be working on. That means that when we go out and we learn a route from another router, that any routes we learn are automatically going to get tagged with an administrative distance of 120. So obviously RIP is pretty high. So this is higher than OSPF, ISIS, which is 115, OSPF is 110, so 115, OSPF is 110, EIGRP is 90, so on and so forth. Now, in order for it to learn routes, you have to be able to find other neighbors on your segment. So if I have a router here and I have a router here, and these guys are running 10.1.1.0/24, this is .1, this is .2, what's going to end up happening is as soon as RIP is turned on, so router RIP, you type in version 2, and you basically say the network of 10, right? Do the same thing over here, router RIP, version 2, and then you say 10net, so just type in 10.0.0.0. That's all you got to do. What that's going to do is the RIP process will look for any interfaces that are enabled, so in the up status, and it'll automatically start sending UDP hellos to the multicast group of 224.0.0.9, which is the RIP link local multicast address. It sends those messages out to UDP port 520. Okay, so if you see UDP port 520, that means it's RIP. So what ends up happening is they go out and they send a hello out, and they send a hello out as well. Now, when you're sending this to this interface, or when you're sending a hello to this multicast address, what's going to end up happening is it's like you're both joining the same group. So it's like you both walk into the same conference room, or the same, you and somebody else who you want to communicate with walk into the same room. You see them and you go, oh, Bill's here. What's up, Bill? Or Bill walks in and sees Rob and goes, oh, hey, Rob. And then you identify yourselves. That's, in this case here, it's going to be a visual recognition. You can see the person. Here, this is a logical recognition. You send the information out. What ends up happening is you send a hello out to this address. And when you send that hello out, other devices are going to get that response. So they're going to, if you were to ping this address right here, you would see, you get replies back in, not from 224.0.0.9, you're going to get a reply back in from the node on your link. So in this case here, if R1 sent a hello out to 224.0.0.9, and with the source IP of 10.1.1.1, what will end up happening is he'll get a reply in from 10.1.1.2, which is R2. And that's how they discover each other. And that's how they go from multicast discovery to unicast communication. So they go ahead, they learn about each other. They go, oh, router 2's here. Oh, router 1's there. Great. I'm going to go ahead and we're going to share our RIP databases with each other. And at that point in time, you are at the point where you'll begin your route propagation process and all that type of stuff. And that's really the high level details to how RIP works. All the IGPs do the same thing. RIP, EIGRP, OSPF. ISIS is a little bit different. We're not going to dive into ISIS at all in this series because, at least not right now, I might do some later on. But that's basically how RIP comes into play. So as long as you understand this concept, you'll be in really good shape. So what I'm going to go ahead and do is I'm going to jump over into the config, and we're going to go ahead and get RIP running between iOS 7 and iOS 8, and we'll take a look at that process real quick because it's actually very, very simple to do. So I'm going to go ahead and I'm going to bring this down just a little bit. I'm going to go over here to iOS 7, and if we look right here, we have a show IP interface brief. I should be able to ping 200.7.8.8, and as soon as it ARPs, why is that not responding? Why is that on gig 2? Oh, I made a mistake. So let me go up here, interface gig 0/2, IP address of 200.7.47.7/24, and then interface gig 0/6, IP address of 200.7.8.7/24. No shut that. Okay, so now if let me just make sure that iOS 8 is squared away before I kick this party off. Show IP interface brief. Gig 4, okay, that should work now. So if I do ping 200.7.8.8, there we go. So now what I'm going to do is I'm going to type in router RIP, and I'll go in and I'll set up version 2, and I'm going to turn no auto summary off. You want to do that because you don't want to have the null routes sitting in the routing table. It's a cleaner way of running RIP. No auto summary basically says if the longest match is the major network statement, so 10/8, go ahead and drop the traffic. I don't want to do that. I don't want to have any null routes in there. We're not going to go into a ton of detail how that works with RIP. We'll dive more into that when we get to EIGRP. So what I'm going to go do now is to type in network of 200, like so. 200, and because we're in a class C range, 200 is above 192. So we have to be more specific. So 7.8.0. And if we do show run section RIP, we look at the config, it should show up 200 7.8, which it does. So now if I was to do a show IP RIP, it doesn't give us a lot of options here, but if we look at the database, we can see that we're enabled the connection on. And if we do a show IP interface brief, I also want to enable interface, or we'll go do router RIP and then network of 200.2.0.0. So enable on the loopback. I'm going to go over here. I'm going to go ahead and debug RIP debug IP rip, and we're going to look at the events. Okay, I'm going to go over here to router 8, go to global config, router rip, no auto summary, version 2, and I'll type in network of 200.2.0.0 and a network of 200.7.8.0. Now that I've done that, what should end up happening on 7 side is we start getting information back and forth. We're sending version 2 update outbound, right? And when we do if we were to ping to, let me do this real quick, type in no IP domain dash lookup. If I do a ping to 224.0.0.9, what I should get is I should get a response from 200.7.8.8, which in this case here is going to be router 8's interface. I also get an update in from my loopback because it's also enabled for RIP. So I ping that IP address, and what ends up, or I should say, I ping that link local multicast group. By pinging that address, it sends out a ping to every other device on that link. So this gig 0/6 interface, and it says, oh, well, I see that router 8 is responding. Router 8 gets the incoming ping and goes, oh, I'm getting a ping, but the source is 200.7.8.7 because that's going to be the source address. He's the sender. In this case here, router 8 is the receiver. So when we get into multicast, this will become a little bit more, we'll dive into that more specifically, but that's basically what's happening here. So if I show IP route, I should see a RIP route here for, let me go ahead and undebug all and let's do another show IP route. We should see a RIP route for router 8's loopback. Okay, pretty simple stuff, right? That's what we're looking for. If we jump over here to router 8 and we do show IP route, we should see router 7's loopback, which we do. So if you have not advertised anything into RIP, in other words, you don't have RIP enabled, or I should say any IGP for that matter, enabled on another interface other than the interface that the protocol is enabled for in order to form the adjacency. So specifically, if I enable the protocol on this link right here, the 200.7.8, what ends up happening is I'm only going to send and receive hellos. I'm going to form the adjacency, and that's as far as it's going to go, because unless you enable it on a loopback or another interface other than the one that the adjacency is formed over, you're not going to see any routes show up in the routing table, because connected is still better than dynamic routing learned. So when I go and I start to bring in these other links, so let's go ahead and on router 7, I'm going to go ahead and type in global config router RIP network of 200.7.21.0 and 22.0. If I go over here to router 8 and I hit the up arrow, I'm going to start seeing more and more prefixes coming in, because that's what router 7 has advertised to me. Now if I do the same thing on router 8, if I type in network of 200.8.21.0 and 22.0, router 7 is going to learn the exact same thing. If I do show IP route, I'm going to be learning in more RIP routes right here. Right? That's basically the process that I'm trying to get across. So because of that, I can go now onto XR21 and XR22, enable them for RIP. So let's go ahead and knock that out real quick. Go ahead and log in to Cisco and Cisco. Go to global config, router RIP, no auto summary, version, it only runs version 2. So we'll type in interface. In this case here is going to be gig 00000, and then we're also going to go on gig 001 and then interface loopback 0. So we do a show config. We can see that that's the configuration that we're going to be deploying. I can actually copy this config for XR22. So I'm going to go ahead and I'm going to commit that config. I'm going to go over to XR22 and do the exact same thing. Cisco, go to global config, copy and paste that config in, and commit it. So what will end up happening is after a short period of time, router 7, if we come in and do a show IP RIP neighbors, we should, oh, I'm sorry, that's only if you're doing unicast, and we're not doing unicast connectivity. If I do a database, we can see a bunch of routes in the routing table now, or in the database. So I see a lot of stuff coming through. If I do a show IP route RIP, we should see a number of routes, right? And eventually, the stuff that's coming from XR21 and 22 will start coming through as well. Right now, we're only learning stuff from, now 22 is coming across, and we're also going to learn 21 momentarily once that comes online and does its thing, because we did enable it. Let's do show IP interface brief. Yep, I got that good to go. So I'm going to go over here back to 7, and I'm not sure why 21's not coming across. Did I not do that correctly? Do show run router RIP. So do show IP interface brief. Make sure that the configuration's right. So gig, oh, that's because I didn't connect it, do the connections to those interfaces. So I'll type in interface gig 0/0/, I'll type in let's go to root. We'll type in interface gig 0/0/0/0/0. IP address in this case would be 200.7.22.22/24. No shut. And we're going to go to gig 1, and we'll do 822 like that, and then no shut. And then I'm going to go ahead and commit that because those interfaces are already good to go for RIP. We'll go back to 7, hit the up arrow, and 21 should be coming across here momentarily. It'll take a couple seconds for it to propagate, but once it's done, we'll be in good shape. So we'll do a show RIP interfaces. We can see it's enabled, which is what we want to have. Let's go back to 7, and it's going to take a couple of minutes for that to propagate. RIP is not fast, but it's something that I definitely think you guys should be aware of. Let's go back to 21 and do a show run router RIP. It's enabled. Show IP interface brief. Those interfaces are up. So ping 200.7.22.7. That should go through. Oh, I put them on the wrong interfaces. That doesn't help. Let me go fix that real quick. So let me go to global config, interface gig 0/0 will be IP address 200.8.22.22/24, and gig 1 will be 7.22. That's my mistake. I didn't pay attention to that. We'll go ahead and recommit that config and do show IP interface brief. Gig 0/0. Yep, there we go. Now 7 should see the route coming across. Let's see, why is this not working? Do ping 200.8.22.8. Okay, what is the deal here? Do show IP interface brief. Gig 1. Okay, that's all squared away. Why am I having a problem here? So these are troubleshooting scenarios that you're going to want to get comfortable with. So, oh, that's because I'm thinking I'm on 20. So I've got the interfaces reversed. So I just messed up. I'm looking here when I'm supposed to be I'm configuring this device. So don't be me. Be smart what you're doing. Let me fix this real quick. On 21, we're going to go to interface gig 0/1. We'll type in IP address is going to be 200.7.21.21/24 for gig, interface gig 0/0/0/0/0/1, IP address of 200.7.21.21/24. For gig 0/0/0, we're going to do 821. We're going to go ahead and commit that config. Okay, that gets rid of that problem. On an XR22, we're going to go to do show IP interface brief. We are going to go to gig 0/0, do show IP route. Okay, I think everything is good now. Let's go to 7 to make sure that that's, there we go. So I've got 21 and 22 in there now, which is what I want. So basically this is what I was looking for. I needed to have that in play before we could go any further. I want to make sure I could do that. Because at some point when we get into BGP, we're going to talk about how this stuff works with BGP. We're going to need the underlying IGP configuration in place. So we are good to go now. So if I was to do a ping to 200.2.0.8 sourcing from loopback 0, that should work. Same thing with 21 and 22 respectively, and I can. So that's where I want to be. I'm going to go ahead and save that config on 7 and 8 real quick, just because I don't want to have to go through that again. And ladies and gentlemen, don't pay attention to where you're configuring stuff, and don't make mistakes like I do. But I'm glad we're able to, they're self-induced. Yes, I know I'm shooting myself in the foot, but that's okay. I'm hoping that it makes you guys laugh, and I can be like, okay, no, you know what, it is what it is. So thank you so much for stopping by and hanging out with me in this video, and I'll catch you guys in the next one. Take it easy, guys.